Hello students, welcome back to the new video lectures. In a previous video we have discussed about the topic that is free fall. We have learned how to derive the formulas and what is the unit of the what do you mean by the free falls, and under free fall we have also discussed about the acceleration due to gravity. But in this video lectures we'll discuss all the three important topics, that is one is mass, another is weight and an object on the moon. So, okay, the three topics that we will be covering in this video lectures, that is mass, weight, okay, and weight of an object on the moon. Okay, so a relation between weight of an object on the moon, and then that is what we are going to discuss. And then in the next video lectures we will discuss thrust and pressure in fluids, and why objects float on or sink when placed on the surface of the waters. And then we will discuss the last topic, that is Archimedes principles and the relative density in the next video lectures. But next week on this chapter is three more video lectures. Okay, two more video lectures will be shared. Okay, so you know what is mass, right? We have discussed this mass in the chemistry section, that is atoms and molecules also. Now what is mass? We have also discussed about the inertia. Okay, inertia in chapter number 9. Okay, we have discussed in the force and the law of motion. In this topic we have discussed the inertia. We know that if more inertia is used, okay, we need more force, right? So here you see, inertia means what? Inertia means what? When you talk about inertia, okay, we have discussed what is inertia in a previous topic. Okay, here we are talking about the mass. I mean, what is mass? Okay, a mass of an object. Okay, a mass, okay, is the measures of its inertia. Okay, measure of its inertia. Measure of its inertia. What is a mass? Measure of its inertia. What is mass? A mass is a measure of its inertia. What is mass? Measure of its inertia. Of its inertia. Clear about this one? What is a mass? Mass is a measure of its inertia. Okay, mass is a measure of an inertia. Okay, so greater the mass, greater will be the inertia. Okay, greater the mass, greater will be its inertia. What is a mass? A mass is the mass of an object, is the measure of its inertia. Greater the mass, greater the mass, greater will be the inertia. Okay. It remains same whether the object is on the earth. Okay, the mass of the object remains same. Okay, mass of an object remains same. Mass of an object remains same whether it is in the moon, whether it is in the moon, earth, or any planets. Okay, any planet, whether it is in outer space. Okay, whether it is in outer space, the mass remains same. Okay, mass of an object remains same. Okay, mass of the object remains same. That is what mass is constant. Okay, mass is a constant and does not change from place to place. If you move from place to place, does it mean that your mass of an object in the equator will be different? Mass of an object in the pole region will be different. It is not like this. The mass of an object remains same whether you place in the equators, whether you place in the poles, or whether you go to the moons, or whether you go to any other planet. Okay, mass of every object remains same. I think you understood about this one. Okay, so this is what we call mass. What is a mass? A mass is a measure of its inertia. I think you're clear about this one. Okay, now let's go and talk about the okay, you see, mass of an object mostly is denoted by the gram. Okay, SI unit of mass is mostly denoted by the gram. Mass of an object is usually denoted by the grams or kg. Okay, so next we will discuss about the next topic, that is what we call as a weight. Okay, what is weight? Okay, so weight is another term. Okay, the weight is what is the attractive force. Okay, the attractive force attractive force, okay, the force attractive force of an object, okay, you see the earth attract every object with a certain force, and this force depend on the mass of an object and the acceleration due to the gravity. What is the weight? Okay, the weight is what? It is a force, okay, it is a force attracted by the earth, okay, it is a force attracted by earth. You can write weight is equal to what? Mass into acceleration due to gravity, okay, acceleration due to gravity. We know that force is what? Force is equal to mass into acceleration, okay. Now our weight is what? Mass into acceleration due to gravity, because acceleration, this is the acceleration done by the acceleration due to gravity, the acceleration is produced by the gravity, okay. So that is what we call as a weight, okay, that's what we call as a weight. So SI unit of weight, okay, SI unit of weight is SI unit of weight, SI unit of weight is what? SI unit of weight, okay, SI unit of weight is Newton, denoted by the capital N. SI unit of weight is what? It is a Newton, okay. SI unit of weight is what? It is a Newton, okay, it is a Newtons, okay. So you see, weight is the weight of an object is a force in which it attracts toward the earth. Okay, what is the weight? Weight is the force of an force. Okay, is the force with which the earth. Okay, with which the earth attract towards it. Okay, weight is then force on which, okay, in which it attract. It is attracted. Okay, it is attracted toward the earth. This is a force attracted toward the earth. Okay, so we can write weight is equal to what? Is I told you weight is equal to acceleration due to gravity. Okay, so now you see a mass does not change from place to place. Okay, mass does not change from place to place, whereas this weight changes from place to place. Okay, if you go to the moon, your weight will be different. If you go to the earth in the equator, your weight will be different, and if you go to the pole, and your weight also will be different. Okay, so the weight is force acting vertically downward. It has both magnitudes. Okay, it has both magnitude and direction. It is a vector quantities. We have discussed what is vector quantity. Okay, is a vector quantities. What is it? Mass weight is a vector quantity. Why is vector quantity? It has both magnitudes, and because it has both magnitudes and directions. Both magnitude and directions. Okay, it is both magnitude and direction. It has both magnitude and direction, so it is weight, the vectors. Okay, weight is a vector quantity. Why? Because it has both magnitude and direction. I think you're clear about what is weight. Okay, as we said, okay, since you see why the weight, okay, why the weight keep on varying from place to place? The question may be there. Okay, why the weight? Okay, if you move to the quarters, your weight will be different. If you move to the pole, your weight will be different. Okay, why the weight keep on varying? Why the weight keep on varying every time? You know that the acceleration due to gravity is, okay. You see. You see, what I was talking is that why the weight keep on varying, whereas the mass does not vary. Okay, let's discuss about this. Okay, you see, let's try to discuss about this from this formula only. Okay, you see, you know that weight is what? Weight is equal to mass into acceleration due to gravity. That means what? Weight, okay, weight depend on mass of an object, and also weight also depend on what? On acceleration due to gravity, that is g. Okay, if you know g, if you know m, okay, mass of an object, then you can easily find out the weight. Okay, but what our question was that why does the weight keep on varying from place to place? Okay, now you see, when you talk about this, you know that the acceleration due to gravity is what? G into mass divided by r. Okay, we said, okay, acceleration due to gravity will be more in a pole, whereas acceleration due to gravity will be less. Okay, will be more in pole. Okay, will be more in pole. Will be more in polar regions, so pole of the earth, whereas will be less. Okay, will be less in equators. Okay, so what is this? You see, acceleration due to gravity is okay. Acceleration due to gravity depend on the distance. Okay, so if the distance is far away, that means acceleration due to gravity will reduce. And if the acceleration due to gravity reduces, that means weight also will be reducing. Okay, now what is it? You see here, if, try to understand this one, if distance r reduces, okay, if r reduces, then acceleration due to gravity g is increased. And if g is increased, now g is directly related to whom? W. That means that if g is increased, w is also, that is weight is also increases. Okay, weight is also increases. Weight also increases. Whereas if I talk about if r reduces, if acceleration distance, the radius of the earth reduces, okay, increases. If it increases, if r increases, we know the acceleration due to gravity is decreased. Okay, it decreases. Then if acceleration due to gravity is decreases, what? Weight is directly dependent on the acceleration. That means weight is directly proportional to the acceleration due to gravity. That means what? Weight also decreases. Remember this one. That is the case that you see acceleration due to gravity is not constant everywhere. Okay, if you go to the equators, your acceleration due to gravity will be more or less, but whereas if you go to the pole, acceleration due to gravity will be more, right? So if you weight yourself, if you weight in the equators, in equator region, your weight will be less. But if you go and weight yourself in the pole, okay, your weight will be more. Okay, but if you go and weight yourself in the moon, that means your weight will be totally might be zero also. Okay, so that means what? If you go and weight yourself in the moon, that means acceleration due to gravity increase. The radius between the earth and the moon is increasing. So if a distance between the earth and the moon is increasing, if it is increasing means what? The gravity's acceleration due to gravity also will be reduced. If acceleration due to gravity reduces, that means weight also will be reduced. Okay, so that is what we are talking about. Okay, so you are clear about this one. I think you are clear about this one. Okay, so from here we will learn that. Okay, we have learned that one thing is what? Weight is directly proportional to the from here we have learned that weight is directly proportional to the from here we have learned that weight is directly proportional to the mass. Okay, weight is directly proportional to the mass. Okay, weight is directly proportional to the mass. So if mass increases, your weight also will increases. Okay, and if weight is also directly proportional to acceleration due to gravity. If acceleration due to gravity increases, then weight also increases. Okay, so that means what? And here we have also learned the difference between the mass and acceleration due to gravity. Okay, let's try to differentiate between these two. Okay, let's try to differentiate between the mass and acceleration due to gravity. Mass and weight. Okay, so what is it? It is a measure of its inertia. Okay, it is a mass of an object is a measure of its inertia. Okay, but here is what? Is a force attracted by the force attracted. Okay, force attracted toward Earth. Okay, the force attracted toward the Earth. This is the first point. Remember this one. What is a mass? A mass, it is a measure of what is a mass? A mass, it is a measure of its inertia. Whereas a weight, it is a force attracted toward the Earth. Okay. Next, SI unit of force. Okay. SI unit of mass. Okay. SI unit is generally a gram or kg. Whereas SI unit of weight is what? Newton. Okay. It is denoted by the small letters. It should be small letters. Okay, and it's denoted by capital N. Next, we have another one that is what? It is constant. Okay, constant. It remains same. Constant. Whereas the the weight changes. Okay, change from place to place. Change from place to place. Okay, changes from place to plus. Clear about this one? Okay, so these are something you see. What is the mass? Mass is a measure of inertia. Second, SI unit of mass is what? Grams or kg. Whereas it is constant, means constant, it remains same in everywhere. Okay, does not change whether you measure the mass of an object in the moon, whether you measure outside the outer space, or you measure in the poles, or you measure in the equators. Okay, it remains same. Okay, whereas when the force attracted toward Earth, okay, the force attracted on the object, okay, the force attracted on the object toward Earth is what we call as a mass. Or is what we call as a weight. Okay, whereas SI unit of weight is what? It is a Newton. Okay, next, changes from plus to plus. It keep on changing from plus to plus. Okay, another point which you can add is what? It is also an what is it? Vector quantities, whereas it is a scalar quantities. Okay, it give only the magnitudes, but here it give both magnitude and directions. Okay, so this is these are some of the points, some of the differences that you can come across, and you can go with a page number. What is it? 146. What are the difference between the mass of an object in its weight? Okay, what is the difference between mass of an object in weight? The mass is the measure of inertia. You can write down all these points, okay, and you can note it down in your answers questions. Okay, next, let's try to calculate the mass of an object on the moon. Okay, let's try to calculate the mass of an object on the moon. You see, by applying the universal law, okay, let us consider that. You see, mass of an object on the Earth, okay, mass of an object on the Earth with which the Earth attract, okay, mass of an object on the Earth with which the Earth attract toward the, the object. Okay, in the same way, mass of the weight of the object on the moon with which the moon attract, okay, moon attract the object toward it. Okay, but whereas the weight of an object in the moon is lesser, okay, than the Earth. Okay, weight of the object, okay, weight of any object, let's say this is our one object, okay, weight of this object in the moon, okay, is less than weight of the object in the Earth. Okay, that means what? Weight of the object will be more in the Earth as compared to weight of the object in the moon. Okay, now let's talk about this one. You see, why it is lesser? Why it is less in the moon? Why it is more in the Earth? Okay, why? Because the force of attraction by the moon is lesser as compared to the force of attraction applied by the Earth. Okay, now let's discuss about this one. You see, let's consider that object. Okay, let the mass of an object be m. Okay, let the mass of an object be m, and let the weight of the moon. Okay, let the weight of the moon be mw. Okay, weight of the moon. Okay, I'm sorry, wm. Weight and moon. Now, let the mass of the moon be mm. Okay, let the mass of the moon is what? Mass of the moon be capital M and M. Okay, and the radius, radius be, okay, radius of the moon be Rm. Now you know that weight is Wm. Okay, weight on the moon. Okay, weight on the moon of an object is equal to what? G M capital MM into small letter m divided by R m squared. Why is this? Why this is happening? Because weight is also in force. Okay, we know by applying the universal law of attraction, universal law of gravitational. What is the universal law of gravitational state? Universal law of gravity, the force between two objects is what? This is what we are getting. Yes, no. This is what is stated in the universal law of gravitational. Force is equal to product of the mass divided by distance, the squares of the distance. Okay, so this is our weight of an object in the moon. Okay, this is a weight of the object in the moon. Okay, let's discuss about. Okay, now by using this, let's try to calculate the weight of the object in the earth, in the moon. So the table is given in your the mass of the earth and the mass of the moons and the mass radius of the moon is given in your textbooks. Okay, so we have discussed that Wm is equal to what? G. Gravitational constant is G is constant, so m into small letter m divided by r squares. So if I put this Wm is equal to what? G into mass of the moon is what? Mass of the moon is 7.36 into 10 to the power 11. 7.36 into 10 to the power 22. Okay, 10 to the power 22 kg into m divided by our radius is already given 1.7 into 10 to the power 6. 1.7 into 10 to the power 6. 1.67. Okay, 1.74 into 10 to the power 6 whole squares. So this is what we are getting, the mass of an object. If you try to calculate this one, it will be G 7.36 into 10 to the power 22 divided by 1.74 into 1.74, okay, into 10 to the power 12 m into m. Okay, so if I calculate this one, so it will be nearly G 7.36 into 10 to the power 10 divided by 1.74. Let's try to calculate this one. 1.74 into 1.74. For 4 fours are 16, 1 in n, 7 fours are 28, 29, 2 in n, 4 ones are 4, 5, 6. 7 fours are 28, 2 in n, 7 cents are 49, 50, 51, 51, 5 in n, 7, 7, 8, 9, 10, 11, 12. 12, 1 in n, 12. 7 sevens are 49. Okay, 7, 12. Okay, then again 1. So 4, 7, 1 divided by 6, 17, 10, 11, 12, 1 in it, 7, 8, 9, 10. 1, 1, 2, 3. So what is the 1, 2, 3, 4? 1, 2, 3, 4. So what is it? It will be nearly here downside, it will be m here. So this will be nearly 3.0276 if you multiply these two. So let's keep this one as the weight of the mass. Okay, let's keep this one as the weight of the object in the moon. Okay, now let's keep this one as the weight of the object in the moon. Okay, now let's try to find out. Okay, let's try to find out the weight of the object in the earth. Okay, weight of the object on the earth. I'm just writing this one in the various side. So 7.36 into 10 to the power 10 divided by 3.0276. Okay, so I'm writing this one. Now let's go with weight an object. Okay, similarly, if I found weight of the mass of the object in the earth is m, mass of the object, weight of the earth is equal to me. Okay, we. That way, if you find that this weight of the object, okay, weight on the object on the earth is equal to what? G me and into m divided by re squares. Okay, so if I substitute this one, G weight on the object, okay, weight on the earth is at 5.98 into 10 to the power 4. 5.98 into 10 to the power 24, okay, into m, divided by RE is what? RE is 6.37 into 10 to the power 6. 6.37 into 10 to the power 6 Newton meter square. So if you calculate this one, you will get nearly 1.474 into 10 to the power 10 gm. Okay, so if you calculate this one, you will get nearly 10 to the power 11. I'm sorry, 10 to the power 11. Okay, so 10 to the power 11. If you calculate this, you will get 1.74 into 10 to the power 11 gravitational constant into mass. Okay, so now we have got these two. Okay, weight of the earth, weight of the object on the earth, and weight of the object in the moon. Okay, now let's try to find out the ratios. Okay, let's try to find out the ratio of the object. Let's try to find out the ratio of the object on the moon. Okay, so if I find weight of the object on the earth, weight of the object on the moon divided by weight of the object on the earth. We know the weight of the object on the earth, okay, on the moon is nearly, you can get 2.431 into 10 to the power 11. Okay, 10 to the power 10 into G into M divided by 1.474 into 10 to the power 11 G into M. Okay, so if I divide these two, G and G cancel, this and this cancel, then you will get nearly, so if I divide this one, okay, so you will get nearly 165 divided by 1000. Okay, so if you divide again, you will get 1 by 6. Okay, so that means what? Weight of mass on earth, on moon, and weight of earth is equal to 1 by 6. That means what? Weight of earth, okay, weight of object in moon is equal to 1 by 6 times the weight of object on the moon. Okay, that means what? You will be lighters. Okay, you will be lighters on the moon. Okay, now let's talk about this is what we are getting. Okay, so what does it mean? What does this mean? Weight of an object on moon is 1 by 6 times of weight of object on earth. Okay, what does it mean? Weight of an object on earth, on moon, weight of an object on moon is 1 by 6 times the weight of an earth. Okay, weight of an object on earth. What does it mean here? Okay, let's try to understand this one first. Now let's talk about this one. If your mass, okay, if your mass, your weight on earth is, your weight on earth is, let's say 30 kg. Okay, your weight on the earth is 30 kg. Then how much your weight will be on the moon? Okay, let's try to find out. Let's try to find out. Is equal to 1 by 6 times of, we know that 1 by 6 times of W, and we know that 1 by 6 times of W is so much 30. So 6 5s are 30. So what is it? 5 kg or 5 newtons. Okay, so this much weight you will get. This much weight you will get in the. Okay, this much weight you will get in the 5 newton. I'm sorry. Okay, this much weight is in the earth. I'm sorry, this is not kg, this is newtons. Okay, so this much weight you will get in the moon. Okay, so in the earth your weight is 30 newtons, whereas in the moon you will get only 5 newtons. Clear about this one? I think you're clear about this one. Okay, I think you're clear about this one. So let's try to do one example. Okay, let's try to do one example. The example number, let's example number 10.5. Example number 10.5. Example number 10 said an object weight is 10 Newton when measured on the surface of the earth. What would be the weight when measured on the surface of the moon? Okay, so weight of the object on earth is 10 Newton. Okay, weight of the object on earth is 10 Newton. And what would be the weight when measured on the surface of the moon? Okay, so weight of the object on moon will be equal to what? We know that 1 by 6 times the weight of the object on earth. So what is it? 1 by 6 into 10. Yes, no. So divided this two. So it will be what? 2, 3 is a 6, 2 5 is a 10. So nearly 5 by 3 newtons, or you can divide 3 ones are 3, 3 6 is 18. Okay, 20 again, 3 6 is 18. So nearly 1.67 newton. Weight of the object on Earth, on Moon, will be 1.67 newtons. Okay, 1.67 newtons. Okay, so this is how we have learned about the weight and the mass, and we have differentiated between the weight and what is the difference between the weight and the mass. Okay, so in this way, in the next topic we will discuss about the thrust and the pressures. Okay, and then we'll discuss about the thrust and the pressure, buoyancy force, okay, and pressures in the fluids. Okay, then last topic that we are going to discuss in the video lectures is Archimedes principle. Okay, so anyway, let's meet in the next video lectures. Bye bye.